Today we are going to learn how to use a distributive property without drawing pictures, so we're going to learn how to use it with an algorithm. Before we do that, we are going to define distributive property. Distributive property tells us how to solve problems in the form A times the quantity of B plus C. So I'm going to go ahead and write that down, and you can start writing it down as well. So there is the definition, and each one of those variables, A, B, and C, stand for a number. We just don't know what the number is. So when you have an expression that looks like that, I'm going to write it again. What that means is you take the number that's on the outside of the parentheses and you multiply it by everything on the inside of the parentheses. So A times the quantity of B plus C equals A times B plus A times C. Our next definition that we have is equivalent expression. An equivalent expression are expressions that are the same even though they look different. If you plug the same variable value into it, it will give you the same value. So I'm going to go ahead and write that down. So let's look at the example that we just had on distributive property. We have A times the quantity of B plus C, and we said that that's the same as A times B plus A times C. So if we just randomly let A, B, and C equal something, let's see, these look different, but let's see if we get the same value. So I'm going to let A equal 2, I'm going to let B equal 1, and I'm going to let C equal 3. So I'm going to rewrite those using those numbers. So A is now 2, B is 1, and C is 3. And then I'm going to do the same thing on the other side. So A is 2, B is 1, A is 2, C is 3. Let's see if we get the same thing on both sides. So here I have 2 times 1 plus 3. 1 plus 3 is 4. So this is 8. And then on the other side, I have 2 times 1 is 2, plus 2 times 3 is 6, which is also 8. So these look different, but when I plug values in for the variables, I get the same answer. That is an equivalent expression. The algorithm for the distributive property, simple, very simple, is you multiply what's on the outside of the parentheses by everything on the inside. So there's the algorithm, but that isn't very helpful without a step-by-step actual algorithm. So let's write down exactly what you do. So multiply outside number by the first term inside the parentheses. Then write the sign. Then multiply outside number by the second term. And then if you have additional terms, you're going to repeat steps 2 and 3 as needed. So this will start to make sense when we look at some examples. Alright, so our first example says use the distributive property to write an equivalent expression for 2 times the quantity of 4 plus 3. Draw a picture if needed. This particular problem we can also do using the order of operations, so we are going to do it both ways. We're familiar with order of operations, so let's do order of operations first. Okay, at the top of my paper I wrote PEMDAS because that's what we use when we use order of operations. So I have 2 times the quantity of 4 plus 3. And then PEMDAS says parentheses. Yes, I have parentheses. So I do everything on the inside of the parentheses first. So I have 2 times 4 plus 3 is 7. Then next is exponents. I don't have. Skip that. Multiplication and division in order left to right. Yes. 2 times 7 is 14. Alright, so there's the first way, doing order of operations. Now the second way, I'm going to do distributive property. Okay, and my algorithm says multiply the outside number by the first term. So I'm going to take 2 times 4 is 8. Then I'm going to write the sign. Then my next step says multiply the outside number by the second term. 2 times 3 is 6. So I have 8 plus 6 is 14. I got the same answer doing it 2 different ways. We typically use the distributive property when we have variables. So let's look at another example. Okay, my example 2 says use the distributive property to write an equivalent expression for 3 times the quantity of 2x minus 10. Draw a picture if needed. So I have 3 times 2x minus 10. My algorithm says to multiply my outside number by my first term. 3 times 2x is 6x. Then I write down my sign. Then I'm going to multiply 3 times 10 is 30. So my answer for this is 6x minus 30. That is my answer. I cannot combine 6x and negative 30 because this one has an x and this one doesn't. So I leave it as it is and I go to my next problem. Use the distributive property to write an equivalent expression for negative 2 times the quantity of x plus 3. So I have negative 2 times the quantity of x plus 3. So my algorithm says I take my outside number and multiply it by my first term. Negative 2 times x is negative 2x. Then I'm going to write my sign. My next step says to multiply my outside number times the second term. Negative 2 times 3 is negative 6. So I have negative 2x plus negative 6, or I can write that as negative 2x minus 6. Either way, they're both correct ways to write that answer. Okay, so my example 4 says factor using the distributive property to write an equivalent expression for 20x plus 2. I am going to draw a picture for this just so we can kind of see it. What we're doing in this example is we're doing the distributive property backwards. So here I have a total thing and I'm trying to figure out, if you think about when we did our activity, how many bags do I need and what's going to go inside each bag. So I'm going to say, I'm going to start with 2 bags because that's my smallest number. And then if I have 2 bags and I have 20 X's, so it's like I have 2 friends and I have 20 X's, how many X's does each friend get? To be fair, each friend would get 10 X's. Okay, then I have 2 positives. How many positives does each friend get? Well, each friend is going to get 1 positive. So then to write this, I write how many bags I have, 2, and then what's inside 1 bag. What's inside 1 bag is 10x and 1 positive. This is my answer right here. So in my last example, I'm going to try and do this with no pictures. It says factor using the distributive property to write an equivalent expression for 8x plus 24. This one is going to have several correct answers. And when you factor using the distributive property, factor means division, basically. So I'm looking for numbers that I can divide easily into 8 and 24. So one of those numbers, when you have two even numbers, 2 always works. So I could have 2 bags or 2 friends. If I have 2 friends and I have 8 X's, then each friend is going to get 4 X's. And I have 24 positives. Each friend would get 12. And then the way that you check that is you just do the distributive property like normal. 2 times 4 is 8x. 2 times 12 is 24. So that checks. Okay, so that is one way to factor that. Okay, then another way to factor that would be, this is the second way. So I could do 4 friends, and if I had 8 X's and 4 friends, each friend would get 2, and then each friend would get 6 positives. And then how do I check that? I check that by doing the distributive property forwards. 4 times 2 is 8x. 4 times 6 is 24. So that one checks. And then there is one more way that I can do. I can factor this one without using fractions or decimals. So I'll do it down here. I could do it with 8 friends. If I had 8 friends, each friend would get 1x or just x, and then each friend would get 3 positives. And then I can check that again using the distributive property. 8 times 1x is 8x. 8 times 3 is 24, and it also checks. So there is 3 different ways to solve that problem. You only need one way. So if you were working on this problem and you had number 1 and your friend had number 3, you're both correct. So you wouldn't have to erase yours to write number 3. It would just be 2 different equivalent answers for the same problem. If you have any questions after watching this lesson, come see me when you get off the bus.